This week we're working on regression, and it might be a little bit more complicated than previous weeks, so I wanted to walk through how we would do this with Excel and not using stat tools or any other add-ins, but what does this process look like? So for Howie's Bakery, we have 140 days worth of data, and in that data, there's some information about what day it is, whether or not it was a sale day, and we want to predict demand based on these other variables. So when you look at this file, you'll see that this is all the data you're given, and this is non-numerical and this is non-numerical, and we can only run regression on numerical variables. So we need to create dummy variables, which you read about in your text. And to do that, basically, I just want some logic that says, if it's Monday, give me a 1. If it's not, give me a 0. And then I'll do that for Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. And then I'll also do it for sales. If it's a sale day, give me a 1. If it's not a sale day, give me a 0. So that logic looks like this. I said if this cell is Monday equal to Monday, and note my fixed references here so that I can drag my cell over and down, then give me a 1, value if true, and value if false, give me a 0. Now I have a numerical variable, and I can spread that column down and over. So like if I made this Tuesday, and then I could take my formula, drag it over, and it would give me a 0 instead. And when I do that for all my logic, I get this data here. So you'll need to create dummy variables, and then you can run your regression. So Excel can handle multiple regression just fine. We don't need stat tools. It does have, it's nicer looking. It has some cool features, but we're not going to worry about it. However, before we run regression, there's something that I want to look at, and this is just good practice, and I'm probably going to need it later anyway. I want correlation. I want to make sure that I'm not running regression on two variables that are highly correlated, and this is basically I'm looking for multicollinearity. So I'm going to run correlation on demand all the way through sale day, and I let it know that I have my labels in my first row. I selected my data, and I'm going to put it in a new worksheet and call it correlation matrix. Hit OK. Okay, so now I have this. At first glance, I don't see anything terribly alarming. So we're going to come back over here, and we're going to run our regression. So we click regression under data, data analysis, and our Y range is demand. That's the variable that we're trying to predict, or a dependent variable. And then our X range is going to be, for our first run, all of our variables. This is my first regression run. I'm going to put it in a new worksheet, and I'm going to say OK. All right. Now, that's a pretty good R squared, but I see right away that I have some variables I need to drop. So this Sunday variable, it's coming up with a numerical error because it's interacting with the other variables in a weird way. And so we probably just need to drop it from our model. And then it looks like Friday also showed up as not statistically significant in this run. I could drop sale day, but I'm going to leave it and see what happens if I drop Friday and Sunday. So when I run regression, all my variables have to be next to each other. So I'm actually going to, I'm just going to, I don't like to delete data, so I'm just going to move it over here for now by right-clicking, cut and paste, and then, so we said Friday and Sunday, so I'm just going to move these out of the way because my variables all have to be together when I run regression. So we'll go to data, data analysis, regression. Now my range has changed a little bit. I only want these variables. I don't want Friday and Sunday anymore. I'm going to call this regression 2. And my regression statistics went up a little bit. My R squared is a little bit higher. And now I'm looking, and so this is saying all of my variables are statistically significant. However, this is kind of a lot for a model. So I'm going to go back to my correlation matrix and see if it looks like Saturday. So I'm just looking for collinearity, but also Sunday. So when I look at demand and correlation, Saturday is like the best predictor of variability. Let's look at days of the week and see. None of these are in sale day. I'd really like to drop some variables from this model. I don't think it needs this many days. So Sunday we already removed. We already removed Friday. Looking at these correlations as being slightly negative, I think they actually aren't going to help us that much in our, and this is just me, kind of thinking over what a good model would look like. And it looks like to me my best, let me do a different color. My best predictors are Saturdays and sale days. These have a correlation, but they're negative, and they're not very strong. So let's try our final model with Saturday and sale day, and then see if we like what we get. And you can work through this in any way that you like. Just write down your thoughts and your justification. So let's go to data again and try this one more time. Demand Saturday and oops, I don't want demand selected in my, there we go, just my independent variables. Okay, and then we'll call this 3. Okay, well, that really hurt my model actually. All right, well, I'll leave it up to you guys to play around, see if you can simplify your model a little bit and come up with something that still has a good prediction, but isn't so complex. So that'll be a fun challenge. And then be sure to review the final questions and make sure that you answer them. So you'll need to think about how helpful this model is. Is there any missing information that would be useful, and how would you obtain it? How would you use it? And this part of the question is really important, so don't skip it. I really want you to think through this exercise and these results, and how you might actually apply this if you were a client, if your business owner client was this business owner.